Welcome. Today let's take a look at Kubernetes and why it is so popular. Kubernetes, originally developed by Google and open-sourced in 2014. It is a container orchestration platform used to automate the deployment, scaling, and management of containerized applications. Kubernetes is often abbreviated as K8s for brevity, and to make it easier to reference in written and spoken communication. It provides a framework for efficiently managing containers, allowing developers to define how their applications run and scale, and ensuring that these applications are highly available and easily maintained. Kubernetes abstracts the underlying infrastructure, making it easier to work with various cloud and on-premises environments. It has become a fundamental tool in the world of containerization and cloud-native application development. A Kubernetes cluster consists of control plane and worker nodes. The control plane components is the brains of the operation, responsible for maintaining the desired state of your cluster. A Kubernetes worker node, also referred to as a minion, hosts the pods, which are the smallest deployable units in Kubernetes, and executes the containers within those pods via container runtime. The API server exposes a RESTful API endpoints that are used to create, read, update, and delete resources within the cluster, such as pods, services, deployments, and configuration settings. It is also responsible for authenticating users and ensuring that they are authorized to perform specific actions within the cluster. This is typically done using authentication methods like certificates, tokens, or integrated authentication providers. API server saves the cluster and resources configuration in etcd. etcd is a distributed and highly available key-value store. It stores all the important data about the cluster's configuration and the desired state of resources, ensuring consistency and reliability. When you create a pod in Kubernetes, you typically define its resource requirements and any constraints or preferences you have regarding its placement. However, you generally don't specify the node where the pod should run. This is where the Kubernetes scheduler comes into play. Its primary responsibility is to make informed decisions about where and how to place pods within the cluster. Scheduler will update the pod information to API server, such as which worker node will be used. The kubelet on that node will receive request from API server and create the containers by using container runtime. Docker is one of the most common container runtimes used in Kubernetes, but Kubernetes is designed to be container runtime agnostic. Other runtimes, like Containerd or runc, can also be used. Kubelet also monitors the health of the pods and takes actions to restart containers as needed. When the resources are created in a cluster, the Kubernetes controller manager is responsible for managing and maintaining the desired state of various resources and controllers in the cluster. It oversees key functions such as scaling pods, handling rolling updates, regulating resource utilization, and maintaining resource consistency, ensuring the stability and reliability of applications and workloads within the Kubernetes environment. Thanks for watching this episode. We just start sketching the surface of the Kubernetes topics. We will cover more about Kubernetes such as Kubernetes networking, role-based access, Kubernetes sizing, and more in the upcoming videos. If you like this video, please like, subscribe, comment, and share this. See you next time.